So good afternoon everyone. Today I am going to discuss about the computer networks unit 2. So topic is medium access control. So coming to medium access control sublayer. So in this data link layer is divided into two sublayers, that is data link control DLC and medium access control. So about data link control we have discussed in the previous class. Now I am going to discuss about the medium access control, that is MAC. So what is mean by DLC, data link control? It is responsible for framing, error control and flow control. So coming to the MAC layer, so it is a medium access protocol, and medium access control, it is responsible for multiple access resolution, that is channelization. So these are the two things we are going to discuss in the data link layer. So we can now I am important topics that is I am discussing, that is MAC, MAC. It is called medium access control sublayers. So coming to the introduction of the MAC. So the in broadcast network, several stations share a single communication channel. In the broadcast network, several stations will share a single communication channel, or are also called as multiple access channels or random access channels. In the broadcast networking, we are having so many types, that is broadcast network and also called multiple access channel or random access channel. In broadcast networking, most important point is that to determine who is allowed to use the channel when more than one user wants to use it. So what is mean by broadcasting? In the broadcasting network, most of the important point is to determine that it is allowed to use the channel when more than one user wants to use it. So in broadcasting network, collisions are the major drawback. So in order to overcome the drawback, we use the multiple access protocol. So what is in the broadcast network, what happened? The collisions will be occurred. So in order to overcome the drawback, we are using the multiple access protocol. So in this below we are having the different charts. Before going to explain that multiple access protocols, first we have to know the major issues in the network, in the which the station should transmit data at a given time. This process of deciding to turn off different stations is known as channel allocation. So this process to be deciding to turn off different stations is known as channel allocation. So channel will be allocated for every device in order to communicate with each other. To coordinate the access to the channel, multiple access protocols are required. So between the channel, if we want to provide a coordinate communication between the channels, we are providing the multiple access protocols are required. So all this being allowed by the sublayer, MAC sublayer. So next, coming to channel allocation problems. What are the channel allocation problems? So in the broadcast network, a single channel is shared by several stations. In the broadcast network, one single channel is shared by several stations. This channel can be allocated only one transmitting user at a time. So these are two different methods of channel allocations. One is static channel allocation, another is dynamic channel allocation. So what is mean by static and dynamic channel allocations? In the static channel allocation, in this method, a single channel is divided among various users either on the basis of frequency or on basis of time. So what is it? What are the channels in the static channel allocation? We having the single channel. The channel is divided into in various users either on the basis of frequency on the basis of time. Either it uses a FDM, frequency division multiplexing, so and time division multiplexing. So depending on the time division multiplexing and frequency division multiplexing, the signals can be divided into various among the users. So depending on these frequencies and time. So in FDMA is nothing but fixed frequency is assigned to each user, whereas time is also fixed time slot to assign to the each user. So for every user, user 1 and user 2, those who are in communication, for the two users, whenever they are transmitting the data, they are providing some channel between between the two nodes. We are providing a single channel. So through that single channel, depending upon the frequency and the time basis, they are calculating the performance of the communication. it either uses the both FDMA or TDMA. So FDMA for for each and every user, we are providing the fixed frequency and timing fixed time slots. So depending on that fixed and frequency, we are calculating the performance of the communication. So in the static channel allocation, so this can be occurred in the static allocation. Next, coming to the dynamic channel allocation. Static means it will be constant, it doesn't move from it doesn't changes its communication. So in the dynamic channel allocation, in this method, no user is assigned a fixed frequency. So nobody we have for any of the user, we doesn't allow any frequency or time slot. So depending upon the user communication, so they will be communicating at any time and any fixed frequency. Okay, so in this method, the user doesn't provide any fixed frequency or time slot. In the static channel, we are providing the fixed frequency and fixed timing slot. So all the users are dynamically assigned frequency or time slot depending upon the requirements of the user. So depending on the user requirements, then we can assign the frequency or time slot in a dynamic channel allocation. So next, coming to multiple access protocol. So what is mean by multiple access protocol? Many protocols can be defined to handle the access to share the link. Many protocols have been handle and access the shared link. These protocols are organized in different groups, that is random access protocol, control access protocol, channelization. So this is called the multiple access protocol. So this is, I am having a small image or graph of this multiple access protocol. So this is, in this we are having three types, that is random access protocol, controlled access protocol, channelization protocols. First, coming to random access protocol, in this we are having Aloha, SMA, CSMA, CSMA CD, CSMA CA. So Aloha means what? Aloha. So in this Aloha, we are having two types, that is pure Aloha and slotted Aloha. Okay, so next coming is CSMA. So what is mean by CSMA? Collision. So coming to the CSMA, in this CSMA, we are having the again some types of so coming to the CSMA, in the CSMA we are having the CSMA stands for carrier sense multiple access and carrier sense multiple access collision division, carrier access multiple carrier sense multiple access collision avoidance. So CD means collision detection and collision avoidance. So these are the two types we are having: CSMA Aloha, CSMA, CSMA CD and CSMA CA. These are the four types will be used in the random access protocol. Next, coming to control access protocol. So in this control access protocol, we are having three types, that is reservation, polling, token passing. In the channelization protocol, we are having three types, again FDMA, TDMA, CDMA. Okay, these are the three types we are having in the multiple access protocol. First one, coming to random access protocol. In random access protocol, no stations is superior to another station and none is assigned the control over the another. So in the broadcasting network, collision is major drawback. There are four types of random access protocols. There are Aloha, pure in the Aloha we are having two types, I said, pure Aloha and slotted Aloha, CSMA, CSMA CD, CSMA CA. So these are the four types will be available in the random access protocol. Coming to the Aloha. So in this Aloha, before going to discuss about the Aloha and pure Aloha and slotted Aloha, it is the random access is called the contention method. In this method, there is no control stations. Any station can send the data. The station can make a decision on whether or not to send the data. This decision depends on the state of the channel, that is channel is busy or ideal. So there is no schedule time for these stations to transmit. They can transmit in random order. So this is called the random access protocol. So in this there is no rule that decides which station should be sent next. So there is no rule which to decide which station should be sent the next. If the two stations transmit at the same time, there is collision and frames are lost. So in this random access protocol, we doesn't have the station can make a decision on whether or not to send the data. Okay, this decision depends on the state of channel, if channel busy or ideal. In this random access protocol, there is no schedule time for stations to transmit. They can transmit in random order. So in the random only they are transmitting the data between sender and the station 1 and station 2, and there is no rule to decide which station should be send next. So if two stations transmit at the same time, there is a collision and frames are lost. So if we provided any sequence numbers or any rules between that communication, we can easily stop the collisions and loss of frames. So whenever two devices send at a time, so the data will be collide with each other, then frames will be lost. So in order to avoid that, we are using some methods in this random access protocol. So coming to the Aloha. So in this Aloha protocol was developed at the University of Hawaii in the early 1980s. Aloha was developed for packet radio networks. There are two versions we are having, pure Aloha and slaughtered Aloha. What is mean by pure Aloha? So it was used as a ground-based radio broadcasting. In this method, stations share a common channel. When two stations transmit simultaneously, collision occurs and frames are lost. So in order to avoid that, we are using the Aloha, pure Aloha. So in this pure Aloha, station transmit frames to station. So we having one station, central station, and multiple surrounding that we having multiple stations, central station and multiple stations we are having. And in the pure Aloha, stations transmit frames whenever they have data to send. So whenever we have the data at the station, that stations will be send that data and that data frames. When two stations transmit simultaneously, there is a collision and frames are lost. So at a time, two stations will be transmitter, the data will be occurred in collision and frames will be lost. Whenever any station transmit a frame, it expects an acknowledgement from the receiver. If we use acknowledgements from between the devices stations, we can easily avoid the collisions and loss of frames. So in this we are having this station that transmit the frames. At the station A, I having the data, I am transmitting that data frames to the station 2, and after receiving the data station 2, he will transmit the acknowledgement to the station 1. So if we provide this type of communication, we don't have any collisions or frame lost. So if acknowledgement is not received within a specified time, so we are providing some specific time. Within that specific time only we have to get the acknowledgement. If the acknowledgement is not received in a given time, the station assumes that the frame has been lost. So in the given time, whatever we have given the limited duration time, in the duration time, if the receiver doesn't set any acknowledgement to the sender, the sender will be think that the data will not the data is lost, or collisions will be occurred. These types of errors will be occurred due to this due to the negative acknowledgement. Okay, next, if the frame is lost, the station waits. Station will be wait for some amount of time for the acknowledgement. After a random amount of time, and sends it again. So if the random amount of time is completed, it sent again the same data until the receiver get that data. So if the frame is lost, the station waits for a random amount of time and sends it again. This waiting time must be random, otherwise same frames will be collide again and again. So whenever two frames try to occupy the channel at the same time, there will be a collision and both the frames will be lost. If first bit of a new frame overlaps, the frames almost finished. Both frames will be lost and both will have to be retransmitted. So this is pure Aloha. So in this I having the diagram. This is the diagram of the Aloha, pure Aloha network. So in this I having the section station 1, station 2, station 3 and station 4. So okay, I am sending the station 1 sending the frame 1.1 and frame 1.2. Station 2 sending frame 2.1, 2.2. This like every station is sending their data. So whenever we send at a time to the central, we having the central station. So these 4 stations are sending the at a time simultaneously to the central station. So whenever at a time they will send, the collisions will be the data frames will be collide with each other, the data will be lost. So this if they provide the collision duration time, within that duration time the data should be received and acknowledgement be given to the receivers. So this is the working of the pure ALAHA. This is the frame in a pure ALAHA network. So this is the venerable time for the pure ALAHA protocol. So in this graph I having the venerable time. So depending on the time duration we have to we have to provide the transmission between sender and the receiver. In the within a given time only the transmission should be completed. So if the transmission is not completed, if the acknowledgement is not received from the receiver, the user will be think, I mean the station will be think the data will be lost or collide with each other. So the data is not reached to the receiver. So again it will be wait for it will wait some amount of time, and then it retransmitted again to the same data to the receiver. So this like the communication will be occur in the pure ALAHA. So F1 is a broadcast frequency. So F1 is in this we are having the broadcast frequency from the individual station, and F2 is a broadcast frequency from the central stations. So next coming to slotted ALAHA. Coming to the slotted ALAHA. In the slotted ALAHA was invented to improve the efficiency of pure ALAHA. In slotted ALAHA, time of the channel is divided into intervals called slots. So what is that? In the slotted ALAHA, slotted means what? I am dividing the channel into number of slots. So slotted ALAHA is nothing but it is to improve the efficiency, invented to improve the efficiency of pure ALAHA. Slotted ALAHA, why we are using slotted ALAHA? In order to improve the efficiency of the pure ALAHA. So in the slotted ALAHA, the time of the channel is divided into intervals called slots. The station can send a frame only at the beginning of the slot, and only one frame is sent in each slot. If any station is not able to place the frame on the channel at the beginning of the slot, it has to wait until the next time slot. So there is still a possibility of collisions if two stations trying to send at the beginning of the same time slot. So this is called the slotted time. So it means what? In the slotted ALAHA, in order to improve the efficiency of the pure ALAHA, the slotted ALAHA in that time of the channel is divided into intervals called slots. The stations send a frame only at the beginning of the slot, and only one frame is sent in each slot. Any station is not able to place the frame onto the channel at the beginning of the slot, it has to wait until the next time slot. So there is still possibilities to have the collisions if two stations trying to stay at the beginning of the same time slot, So next coming to the diagram of the slotted ALAHA. So in this I have in the diagram, so station 1, station 2 and station 3 and station 4. So I am sending the data frame 1. So in this I am dividing the channel. In this I am dividing the channel into number of slots. See, this is the slots. The time of the channel is divided into intervals called slots. Okay. The station can send frame only at the beginning of the slot and end of the, and only one frame is sent to the each slot. Okay, so in this slotted ALAHA, the assumptions all the frames are same size, time is divided into equal size of slots, nodes are synchronized. By using this slotted ALAHA, channel utilization is achieved around 37% efficiency. Throughput for slotted ALAHA is S is equal to GE power minus G. Advantages of the slotted ALAHA, it double the efficiency of ALAHA, highly decentralized, simple to implement. Drawbacks, it have some drawbacks, that is collision waste slots, ideal slots. So this is called the slotted ALAHA, and so this is the venerable time for slotted ALAHA protocol. in this we are having the collisions. So this is the beginning and end of the frame. We are having the B, A, C, beginning. These are the frames I am having. So at the vulnerable time, here the data is not received. Here the collisions will be occurred at the with C. A collides with C. So beginning and ending, the A and C is sent at a time, so that the two data are collide with each other. And here we are here the arrow mark is showing that A collide with C. A is colliding with C. So this is called the vulnerable time for a slotted ALGA protocol. So next coming to carrier sense multiple access protocol. So what is mean by carrier sense? It can be used to reduce the collision, but it cannot eliminate, Why we are using carrier sense multiple access? In order to reduce the collision, but it cannot eliminate it. In CSMA, each station must be medium before sending. So medium before sending. So in this CSMA is based on the principles of carrier sense. So in this whatever the problems occurred in the ALGA, in order to minimize the chances of collision, we are using the CSMA. So the station sends the carrier or channel before transmitting a frame. It means the station checks whether the channel is ideal or busy. The chance of the collision reduces to great extent if a station checks the channel before trying to use it. So in this carrier sense SSMA, we are having small diagram. This is the diagram of the channel traffic, that is CSMA. So in this we are having space or time model of the collision in CSMA. So in this we are having the throughput. Throughput. This is the area where the both signals exist. This is the area where both signals are exist. This is the area where A's signal exists. In the yellow color shaded, it is a signal. Signal of A it is, and blue color is the signal of B. At the middle we are having this brown color, that is called the both signals exist here. Both A and B signals are exist between the middle of the area. Okay, so here A, B, C, D are having. So A and B starts at a time T1 and C starts at the T2. So okay, this is the timing, and this is called the CSMA. This is called carrier sense multiple access. So in this method, in this CSMA we are having three methods: non-persistent CSMA, one persistent CSMA, I persistent CSMA, P persistent CSMA. Coming to the, this is the, so this is one graph we are having. Needs to transmit. I need to transmit the data. The CSMA will check the channel is ideal or not. If the channel is ideal, then it will if channel is ideal or not. Ideal means traffic is there or not. Free ఛానల్ అనేది ఫ్రీగా ఉందా లేదా అని చెక్ చేస్తుంది. ఛానల్ అనేది ఫ్రీగా ఉంటే మనం ట్రాన్స్మిట్ చేసేస్తాము. ఫ్రీగా లేకపోతే మళ్ళీ నో దగ్గరికి వెళ్ళి మళ్ళీ రిపీట్ అవుతుంది. ఓకేనా? సో దిస్ ఈస్ ద కమ్యూనికేషన్. సో అండ్ కమింగ్ టు the chance of collision still exists because the propagation delay. So the frame transmitted by one station takes some time to reach the other station. So in the meantime, the other station may sense the channel to be ideal and transmit its frames. This result in the collision. There are three different types of CSMA protocols: non-persistent CSMA, I-persistent CSMA, N-persistent CSMA. Coming to the non-persistent CSMA, what is mean by? So this is the behavior of the three persistence. First one is a one persistence channel. So in this we are having the diagram, and this is the non-persistence. This is a M persistence. So these are the this is a P persistence. So these are the three persistence we are having in the CSMA. Next, coming to one persistence. What is mean by one persistence? In one persistence CSMA, when the station having a frame, in the one persistence CSMA, the station having a frame to transmit. If the channel is busy, the station reattempt the channel. సో ఏంటంటే స్టేషన్ ఏ స్టేషన్ బి ఉందనుకోండి. సో స్టేషన్ ఏం చేస్తుంది? డేటాని సెండ్ చేస్తుంది. డేటాని సెండ్ చేసినప్పుడు ఛానల్ ఏం చేస్తుంది? ఛానల్ అనేది చెక్ చేస్తుంది. సో వన్ పర్సిస్టెంట్ అనేది ఏంటి? సిఎస్ఎంఏ ఎందుకు చూస్ చేస్తున్నాము, ఛానల్ అనేది ఫ్రీగా ఉందా లేదా అని చెక్ చేస్తాం. ఛానల్ బిజీగా ఉందా, ఐడియల్ అంటే ఫ్రీగా ఉందా అని. ఛానల్ అనేది ఫ్రీగా ఉంటే, ఇఫ్ ఛానల్ అనేది బిజీగా ఉంటే స్టేషన్ అనేది మళ్ళీ రీఅటెంప్ట్ చేస్తుంది, మళ్ళీ ట్రై చేస్తుంది. ఛానల్ ఫ్రీ అయ్యేదాకా మళ్ళీ రీఅటెంప్ట్ అనేది జరుగుతుంది. ఛానల్ ఫ్రీ అయ్యేదాకా అది రీఅటెంప్షన్ అనేది జరుగుతూ ఉంటుంది. ఫస్ట్ ఛానల్ చెక్ చేస్తాం, బిజీగా ఉంది, మళ్ళీ కొంచెంసేపు వెయిట్ చేసి మళ్ళీ ట్రై చేస్తాం. ఛానల్ మళ్ళీ బిజీగా వస్తుంది, మళ్ళీ ట్రై చేస్తాం. మళ్ళీ ట్రై చేసినప్పుడు అప్పుడు ఫ్రీగా ఉందనుకో మళ్ళీ మనం సెండ్ చేస్తాం. సో ఇలా అనమాట వన్స్ పర్సిస్టెన్స్ అంట. ఇఫ్ ద ఛానల్ ఇన్ ద వన్స్ పర్సిస్టెన్స్ ఇస్ CSMA when the station having a frame to transmit, if one channel is busy, the station waits until it become ideal. When the station detects the ideal channel, it immediately transmits the frame. So this method has the highest chances because two or more stations may find channel to be ideal at the same time and transmit their frames. So in the below, this is the diagram. In this having the small diagram of the once persistent. So I didn't represent here. So the in this middle of the communication, I am using the wait randomly and channel. So channel will be used to check whether the channel is busy or not. If the channel is busy, it will be wait for some amount of time. After waiting that, it will be ideal. It will be goes to the ideal and data will be transmitted to the user. So that is called the I1 persistent. Okay. Once persistent station can transmit. Next, non-persistent. In non-persistent CSMA, when a station having a frame to transmit, if the channel is busy, the station waits a random period of time. If the channel is ideal, then the station can transmit the packet. That is called the working of this non-persistence. So non-persistence means what ma? If the station in the non-persistence, when a station having a frame to transmit, if the channel is busy, then the station waits a random period of time. సో ఛానల్ బిజీ అయితే ఏమవుతుంది, అది వన్ పర్సిస్టెన్స్లో ఛానల్ బిజీ అయితే మళ్ళీ రీఅటెంప్ట్ చేస్తుంది, మళ్ళీ వెంటనే రీఅటెంప్ట్ అనేది జరుగుతుంది, ఛానల్ చెక్ చేస్తూ ఉంటుంది. సో దీంట్లో నాన్ పర్సిస్టెన్స్ CSMAలో ఛానల్ అనేది బిజీగా ఉంటే స్టేషన్ అనేది సమ్ అమౌంట్ ఆఫ్ టైం అనేది వెయిట్ చేస్తుంది. సో ర్యాండమ్ పీరియడ్ ఆఫ్ టైమ్ ద ఛానల్ ఈజ్ ఇన్ ఐడియల్, ద స్టేషన్ క్యాన్ ట్రాన్స్మిట్ ద ప్యాకెట్. సో దిస్ ఈస్ ద కమ్యూనికేషన్ ఆఫ్ ది నాన్ పర్సిస్టెన్స్ CSMA. నెక్స్ట్ P persistent CSMA. It reduces the probably of collisions. It reduces the collisions of pre-persistent CSMA is used. So when pre-persistent CSMA, when station having frame to transmit, the channel is busy, then use the backup processor. If the channel is ideal, the station can transmit a packet. So this is the working of one persistent, P persistent and non-persistent. So okay, so this is the P persistence. Coming to CSMA CD. In this, what is mean by CSMA CD? Collision in carrier sense multiple access collision detection. In the CSMA, collision is detected, then the transmission station release the jam signal. This signal alter the other stations. So in this protocol, the station sends the channel before transmitting the frame. If the channel is busy, the station waits. The additional features in CSMA CD is that stations or detect the collisions. The station abort the transmission as soon as they detect collision. This feature is not present in CSMA. The station continue to transmit even through they has been occurred. So this is called has been occurred. In this CSMA collision, having the flow diagram. So need to transmit. If I need to transmit the data, then I will send the data. If the data, then I will check the according to the CSMA, I am going to check the channel is ideal or not. If the channel is ideal, then it will be moved to the start transmission, and start transmission will be goes to the collision, and collision will be goes to then, and if the collisions is not avoided, then it will be go back to the start transmission, and until that avoid the collisions, then it will be done and it will be end. So at the collisions, it will be goes to the if there is a collision, it will back off to the need to transmit, again it will be transmitted in the ideal. This like the communication will be is the flow of the diagram. And in this CSDMA station that sends the data on the channel continue to sense the channel even after data transmission. If the collision is detected, the station aborts its transmission and waits for a random amount of time and send its send its data again. So as soon as collision is detected, the transmitting station releases a jam signal, and jam signal alerts other stations. Stations are not supported to transmit immediately after the collision has sended. So this is the CSMA CD. So in this having frame format of the CSMA CD. So in this frame format I am using in this frame format in the CSMA CD. I am having the frame format, that is in the frame we have PR, that is preamble preamble with 7 bytes synchronization, SFD start frame delimiter, DA destination address, SA source address, length, data, PAD mini frame size, and that is 6 bytes, and FCS error detection methods. These are the different things available, different fields available in the frame format of the CSMA CD. So this is the synchronization. So PR preamble, what is mean by preamble? PR means preamble. This is the 7 byte field which is user for synchronization. Next SFD start from delimiter. So this is 1 byte field which is used for start of a frame. So DA, this is a 2 or 6 byte field which is used to address of the destination. So this is called DA. Next SA, this is the source address. So source, so this is a 2 to 6 byte field which is used to address of the source, that is called the SA. Next L, what is mean by L? Length. This is a 2 to 6 bytes field which is used to indicate the length of the data. So data is called, this is a 6 byte field which is used to specify the data. pad, this is the 6 byte field which uses to specify the minimum frame size. Next FCS, in this we having the 4 byte field which is used to specify the error detection method. CSMA CA. CA means CA is a acronym of collision avoidance. Next coming to CSMA CD. Sorry, CSMA CA. CSMA CA. So in this protocol is used wireless network because they cannot detect the collision. So the only solution is collision avoidance. It avoids the collision by using the 3 basis technique, that is interframe space, contention window, acknowledgement. So in this CSMA stand for collision avoidance. So CSCD is used in wireless networks. So to overcome the drawback of CSMA is CSMA CA is introduced. So okay, CA uses 3 methods: interframe space, contention window, acknowledgement. What is mean by interframe space? In this method, each station priority can be defined. Connection window is nothing but, in this method, whole amount of time is divided into slots. Acknowledgement, so in this method acknowledgement and time is used to guarantee transmissions. Next, control access protocol. In control access, the station consults. And the next coming to control access, this is the diagram of the transmission. Previous we have discussed the same as that. So need to transmit, it is ideal that it moves to if it is ideal, it moves to the next and it will be execute the processor. If it is not ideal, busy, it wait for random time, then it will again send it will again receive the, if it is receive the data, it will be transmitted and the communication be occurred in this type. Okay, next coming to interframe space. What is mean by interframe space. In this method, station period can be specified. Whenever the channel is found ideal, the station does not transmit immediately. So it waits for a period of time called interframe space, that is IFS. When channel is sensed ideal, it may be possible that some distant stations may have already started transmitting. So therefore, the purpose of IFS time is to allow this transmitted signal to reach its destination. If after this IFS time channel is still ideal, the station can send the frames. So this is called the interference space. So next, contention window. In the contention window is the amount of time divided into slots. Station that is ready to send choose a random number of slot as its waiting time. The number of slots in the window change with the time. This means that it is a set of one slot for first time and then doubles each time. The station cannot be detect an ideal channel after the IFS time. In this contention window, the station need to be sense the channel after each time slot. Next, acknowledgement. So despite all the precautions, collisions may occur on the destroy the data. Positive acknowledgement and the timeout timer helps guarantee that the receiver has received the frame. This is called the acknowledgement. Next, coming to control access protocol. So in the control access, the station consults one another. In the control stations, in this method, the station consult each other to find which station has a right to send. Which station has a right to send? A station cannot send. So in this in the control access, the station consults one another to find which station has a right to send. So a station, the station cannot send unless it has been authorized by other station. The different control access methods are required, that is reservation, polling, token passing. Coming to the reservation. So in the reservation method, a station needs to move a reservation before sending data. So the time is divided into intervals. In each interval, a reservation frame proceeds the data frames sent in that interval. The below figure shows the reservation access method with 5 stations and 5 mini slots reservation frames. In the first interval, only station 1, 3, 4 have made is made at the reservation. In this second interval, only station 1 has made reservation. So this is the diagram I having here in the reservation. So this diagram having having a small diagram. So in this diagram, whatever the reservation means, what reservation means 0 having the values. So station 1, what is mean by reservation ma? So in this reservation method, station needs to make a reservation before sending the data. Data send చేయక ముందనే మనం reservation అనేది చేసుకోవాలి. For example, if you are traveling in the bus or a train, so before going to Hyderabad, so if you want to go to the Hyderabad, so you want to make the reservation tickets on bus or train. So before if you reserve the seats, you will sit in your place only. Nobody will be occupy that place. You only occupy that place. Okay. So nobody take your place. Okay. So this is the example. So here we are, whenever we are before sending the data, then only we have to reserve the place. Okay, the station needs to make the reservation before sending the data. Time is divided into intervals. In each interval, a reservation frame proceeds the data frame and sent in the interval. So having the reservation access method with 5 stations and 5 mini slots reservation frame. In the first interval, station 1, 3, 4 have the first station 1, 3 and 4 have made reservations. 1, 3. So this is the station 1, 3, 4 has reserved for the values of the frame. Okay, in the second interval, only station 1 has made reservation. So this is called the diagram. So this is the our format reservation frames. So the reservation frames is reserved in the station 1, station 3 and station 4. Second interval, station 1 is reserved. So this is the reservations. Next coming polling. What is mean by polling? So polling works with topologies in which one device is designated as a primary station and the other device as a secondary station. All the data exchanges must be made through the primary device even when the ultimate destination is secondary device. So this method uses the two functions, that is select or poll. Select or poll. So select is nothing but if the primary station wants to send the data, it tells the secondary station to get ready to receive. This is called the select function. Poll is called if the primary station wants to receive data, it asks the secondary station if they have anything to send. This is called the poll function. We are having two types in the polling, select and poll. In this polling access method, okay, next coming to so in this polling primary station, having the primary station and secondary station. Primary station send the select function to the secondary station B. Then B sends the acknowledgement to primary station for data sending. So next step, primary station send data to the station B. After receiving the data, B sends acknowledgement to the primary station. So next coming to token passing. In this method, the stations in a network are organized in a logical ring. In other words, for each station there is a processor and the successor. Processor and the successor. So in this primary station wants to receive data, it asks the secondary station by using poll function, but station A sends negative acknowledgement to primary station. Next step, primary station sends poll function to the station B, then it sends data to the primary station. After receiving the data, primary station sends acknowledgement to the secondary station B. So the token method is used to those networks where the stations are organized in logical ring. Such a special packet called the token circulated through a ring. Stations that passes the token has the right to access the channel. Whenever any station has some data to send, it waits for the token. It transmits the data only after it gets procession of token. After transmitting the data, the station release the token and pass it to the next station in the ring. Any stations that receives the token has no data to send. It simply passes the token to the next station in the ring. So this is called the token passing. Next, channelization. What is mean by channelization protocol? The token passing network stations do not have to be physically connected in a ring. The ring can be logical one. The below figure shows the four different physical topologies that are create the logical ring, that creates the logical ring. So in this physical channelization protocol, having the three types of channelization: frequency division multiple access FDMA, time division multiple access TDMA, core division multiple access CDMA. These are the three types of channelization protocols available in the channelization protocol. Next, in the physical ring, having the physical ring. So in the physical ring, the four stations are connected in a circle, in the circular way. Okay na, in a circle, four stations are connected with each other: station 1, station 2 and station 3 and station 4. The physical ring topology, when station sends in the physical topology, ring topology, a station sends the token to its successor. The token cannot be seen by the another station. The successor is the next one in the line. So station anedi, it doesn't observe. The station sends the token to its successor. They cannot see in the other station. So in the sequence manner, in the order way, in the given order, in the sequence, the token will be passed to one after another. So the token cannot be see the other station. The successor is the next one in the line. This means that the token does not have to have the address of the next successor. This problem, the medium between two adjacent station fails, the whole system fails. So what is the mean of this main theme? So physical ring lo manaki four stations unnai. Four stations anedi station 1, station 2, station 3 and station 4. So manamu data anedi, whatever the tokens we are having, that cannot be seen by the other station. So the tokens doesn't see the other stations. The successor is the next one of the line. So this means the token does not have any address. So whatever the station we are having, the station doesn't have any address of the other station. It just pass to the next successor. This due to this the media there is a problem between medium between two adjacent stations that fails, the whole system will be fails. So that is called the physical ring. And it operates in the reverse direction compared with the main ring. The second ring is for emergency only, such as the spare tire of a car. Okay, next is coming to the bus ring. In the bus ring topology, also called a token bus, the stations are connected to a single cable called as bus. So next coming to star topology. In the star ring topology, the physical topology is a star. There is a hub, however that acts as a connector by using by wiring inside the hub makes the ring. And next coming to channelization protocol. In the channelization protocol, and we having the three tabs. Channelization is a multiple access method in which available bandwidth of a link is shared in the time frequency as through code between different stations. Okay, so there are three different types of channelization protocols. One is FDMA, TDMA, CDMA. What is mean by FDMA? The frequency division multiple access. The available bandwidth is divided into frequency bands. So whatever the band we are having, that band is divided into frequency bands. Each station is allocated a band to send its data. To prevent the station interference, the allocated bands are separated from one another by small guard bands. And that prevent the station interference. FDMA is different from FDM, frequency division multiplexing. FDMA is a physical layer technique, whereas FDMA is a access method in the data link layer. So in this FDMA, having the diagram, this is the diagram of the FDMA. In this frequency multiple access, the frequency is divided into available bandwidth is in this frequency division FDMA, the bandwidth whatever the bandwidth we are having, that bandwidth is divided into frequency bands. These are the frequency bands. I am sending the data to the data 1 at the data station 1. Data is sended, and station that data is received by the so this is my data. Okay, this is the band, this is the band 1. So this is the bandwidth. Bandwidth is divided into number of slots, and band divided number of frequency bands. This is 1 2 3 4. So first frequency I am sending, and at the data 1 station 1, at the station 2 we are having second frequency, at station 3 we have third frequency, at station 4 we have fourth frequency. So bandwidth frequency, this is 4 is divided. So this is F. Okay, and this is the common channel, and this is a silent, and this is the data. In this we are having the data. Okay, next coming to TDMA, time division. So time division multiple access. The bandwidth of a channel is divided among various stations on the basis of time. So each station is allocated a time slot during which it can send its data. Each station must know the beginning of its time slot. The TDMA is also different from TDM. TDMA is a physical layer technique, whereas TDMA is an access method in data link layer. So next in this TDMA we are having the diagram. This is the TDMA. So what we are doing in the TDMA? The TDMA bandwidth channel is divided among various stations. This is the channel 1, channel 2, channel 3 and channel 4. The channel is divided into various stations among the basis of time. Each station allocated time slot during which it sends its data. Each station must have beginning of the time slot. TDMA is different from TDM. Time division, TDMA is a physical layer technique, whereas TDMA is access the method in data link layer. So this is the main diagram of the time division multiple access. In this we are having the stations, 4 stations. In the middle I having the common channel. So in this channel we are dividing the bandwidth into 4 different channels, and in the station 1 I having the channel 1, in station we have channel 2, in station 3 and channel 3, at last we are having channel 4. So this is the diagram of the TDMA, time division. So CDMA is nothing but TDMA. In CDMA all the stations can transmit data simultaneously. CDMA allows each station to transmit over the entire frequency spectrum all the time. The multiple simultaneous transmission are separated using coding theory. In CDMA, each user is given a unique code sequence. So this is called the CDMA. In this CDMA, I am having the diagram. This is the D1 C1, D2 C2. This is my data. D1 plus D1 into C1 plus D2 into C2 plus D3 into C3 plus D4 into C4. So this is my data. So this data is divided into number of channels. So this data, whatever the data frequency spectrum of all time. So and unique code, this is the unique sequence code, and it is divided into the stations. So D1 into C1 is given to station 1, D2 point C2 is given to station 2, and D3 point C3 is given to station 3, and D4 is given D4 into C4. This is the division of the data. This is the simple code which is divided in the various stations. So next, coming to working of CDMA. Let us assume that we have the 4 stations, for station 1, station 2 and station 3 and station 4, and they are connected with the same channel. The data from the station 1 is D1, and station 2 is a D2, and station and so on. The code assigned to station 1 is C1, and station 2 is C2, and so on. These assigned codes have 2 properties. It is multiple each code by another, multiple each code by another. Another we get 0. If we multiply each code itself, we get 4 number of stations. So okay, so this is the working. When these 4 stations send data on the same channel, then station 1 multiplies its data by its code, that is D1 into C1. Station 2 multiplies its data by its code, that is D2 into C2, and so on. The data that goes on the channel is the sum of all these channel terms, D1 into C1, D2 into C2, and D2 into C3, and D4 into C4. So any stations that wants to receive data from the channel multiplies the data on the channel by the code of the sender. So this is the example. Suppose station 2 wants to receive the data from station 1. It multiplies the data on the channel by C1, the code of station 1, because C1 into C1 is 4, but C1 C2 into C1, C3 into C1, and C4 into C1 are the all zeros. Station 2 divides the result by 4 to get the data from station 1. So data is equal to D1 into C1 plus D2 into C2 plus D3 into C3 plus D4 into C4 into C1. So now I am multiplying all the values with the C1. So D1 into C1 into C1, D2 into C2 into C1, D3 is into C3 into C1, D4 into C4 into C1. So now I am telling that whatever the 3 things having C1, C1, C1 are all the zeros. So I am providing the zeros. D1 into C4, D1 into 4, D1 into 4 plus 0, 0, 0. So D1 into 4 by 4, okay, is equal to D1. 4, 4 cancel. So D1 will be get. So this is the example. Okay. So these are the second unit we have explained here.